All right, guys. So we wanna solve only the highlighted items in this week. So firstly, let's solve part A here. So before starting officially solving the question, so we see that in this week's topic, the variation of the method has been discussed in order to enable us finding the particular solution. So for doing that, there is assumption that we will see it is u1 prime y1 plus u2 prime y2 equal to be 0. So why we do this? Well, I will share my handwritings, and in this web link, you can see that why. Because it's too far from the topic, so I won't talk about this. Now, let's talk about part A, y double dash plus y equal to 10 of x. So obviously the homogeneous part, the characteristic equation can be obtained as r squared plus 1 equals 0. Therefore, the complementary solution will be cos of x plus c2 sine of x. So I choose y1 to be equal cos x and y2 to be equal sine x. Now, the method of the variation of the parameters, we try to find the particular solution, yp. Well, 10 of x is the guy that we are unable to use the classic methods which we have been taught and seen in Math2800 and Math2800. So what we want to use here is the variation of parameters. Now, yp, let's assume that it is u1, y1, u2, y2. In fact, in the constant coefficient in second order, instead of u1, we could see that u1 and u2, they were constant. So their derivative u1 prime and u2 prime would be 0. And here, instead of constants, we will have, instead of constant numbers, we will have functions, but the assumptions that tells us u1 prime y1 and u2 prime y2 is 0, is still we will see. Now, from y here, we see that yp prime is this guy for expressions. Now, due to that assumption or hypothesis, we see that u1 prime y1 addition to u2 prime y2 is equal to 0. Now, yp prime reduces to into two expressions. Yp double dash is this guy, u1 prime, y1 prime. And from here, now, we're going to substitute yp double dash and yp into the homogeneous, actually, into the not homogeneous, just into the original ODE. So we see that if I sub it, we will sub it here, yp. So this is yp double dash, these four expressions plus yp is this guy. Now, we see that the red guys, u1, y1 double dash and u1, y1, we factorize u1, and the purple ones, they've got u2 in common, so I will factorize these. Now, I see that since the red part, y1 double dash, and purple part, y2 double dash, y1 and y2, they are the solution of the homogeneous part of the ODE. Therefore, these two expressions inside parentheses is 0, and also this one as well. So what we will be left is just this guy. So I've got this guy and the original assumption, this guy. So we can find u1 prime and u2 prime by using these two simultaneous equations. So what we can use is Kramer's rule. So we see that we can use it. So after using this Kramer's rule, u1 prime is this guy and u2 prime is this guy. So we where W is the Wronskian of y1 and y2. Remember that we chose y1 to be equal cos x and y2 to be equal sine x. I have written some explanation about Kramer's rule. Probably you haven't seen. So let's assume that ax plus by equals c, a prime x plus b prime y equals c prime. So I multiply the first equation by minus ai prime. So it will be like same as this one. And I will, actually it won't be equal like this, but if I multiply the second expression by a, then these first expression, they will be the same. So they will be cancelable. So I will be left like these guys. So if I add them together, I will have this one. So this guy is like, I can write it in terms of determinant here. And the right hand side, ac prime minus a prime c is also can be written like in determinant. Now, why is this one? I am able to obtain x as well. Now, back to the original question, y to sine x. Now, actually, y1 is cos x. So I can sub there as well. So instead of u1 prime, u2 prime, we can use these two formulas. You can write these two formulas in your cheat sheet, but we can also, if you don't remember them, you can just start solving these two simultaneous equations. So it is easy to just multiply the second guy by sine and the first equation by cos x. So u1 prime, u1 prime expressions, they will cancel. So we can obtain u2. So u2 will be this guy minus cos x. And u1 prime, instead of like doing this, we can use the formula minus y2 f of x sine x 10x. So y2 sine minus f of x is the right hand side of the equation, 10 of x. And w was the Wronskian of cos and sine. So you see that w as I have calculated here. So now instead of 10, I can write sine over cos. So I can obtain this guy. So u1 will be this guy here. So if I use some identities in trigonometric equations, I will get this. The second integral is obvious. The first integral is the integral of sec of x, and integral of sec of x is also famous, so which is equal to log of absolute value of sec x plus 10x. For obtaining integral of secant of x, you can multiply secant of x is like to sec x plus 10x and divided by sec x plus 10x. And you can see that the derivative of this denominator here is just numerator. So it's easy to obtain the integral of sec of x here. Therefore, we've obtained u1. We had the u2 already. So yp is this guy here. And this is so we can just do some simplification. This guy and this guy. We will have this guy as yp. So the general solution will be the addition of the complementary solution plus the particular solution. All right. Okay. We want to do the part B. Part B, so constant second order linear ODE, right, non-homogeneous. So for finding homogeneous solutions, we've got this characteristic equation coming from here. And by decomposing, we can see that this one. Therefore, y1 will be exponential of 3x and exponential of minus 2x. So yp, we can use the classic method, but we want to practice the variation of the parameters. Yp is this one. So w is just quickly Wronskian, y1 by this one. So y1 e to the 3x. So this one. Y2 is this one. Y2 prime is this one. So determinant, okay. So I will have minus 5 e to the x. So using those two formulas for finding u1 prime, so u1 prime is this guy, this fraction, so subbing whatever I have, f of x, if you remember, e to the 2x, right hand side, it's here. So simplification, and I will have only this guy here. And u1 will be integration of this guy, so it will be minus 1 over 5 e to the minus x. So u2 prime is just again substitution, y1 is e to the 3x, then I will have this one. So u2 is also simple, so yp will be this guy. So some simplification will give me this one, a coefficient of e to the 2x, which is similar to the right hand side, the non-homogeneous part. So y is this guy. All right, you don't have any question. So one of your questions in mid-semester exam will be this one, part C. So for part C, for obtaining homogeneous part, it will have like 3 marks, I think. So for homogeneous parts, let the ODE be as it is, as it looks. So you don't have to divide it by x squared, okay? But for obtaining non-homogeneous YP, we have to make it as standard form in terms of the lecture notes. But right now, we don't divide it by x squared. So Euler-Cauchy equation, okay, this is called because the degree of the coefficient polynomial is compatible with the order of the derivative. You see here, and you have seen the similar question in one of the questions of the workshops in Math2800. So the change of variables, the trick that we want to solve this one, unlike the constant coefficients, we don't use exponential of Rx to get the characteristic equation. Instead, we use y to the x to the p. Okay, you need to mention if you, so for, as I said, you can write or memorize the u1 prime and u2 prime in the cheat sheet, but you shouldn't use formula for the Euler-Cauchy equation. You should say that, okay, I will use this substitution, y equals x to the p. So y prime is this one and y double dash is this one. Then you will sub inside the ODE. So x squared, instead of y double dash, I've got this one. Y prime is this one, and this is y. So after some simplification, I will get this one. Let's assume that x is bigger than 0. Therefore, x to the p is bigger than 0. Then I will, if I factorize, I will get this bracket times x to the p. Okay. And you can see from here as well. So p squared minus 3p plus 2 equals 0. I divided both sides by x to the p. Now, let's go back to the ODE. Here, you might say that, okay, my characteristic equation will be p squared minus 1 less. whatever the coefficient minus 2, it will be minus 3p plus 2 equals 0. Yes, you are right, but don't use that. You should mention that y equal xp. So a couple of lines here, please write it. You don't have to write that these lines. So then you've got this one, so you can discover the roots of this quadratic expression. P equal 1, P equal 2. Therefore, yes, y complementary is this guy. X to the P1 plus C2 times x to the P2, which is this one. So y1 is this one, y2 is this one. Again, we try to find yp by using the variation of the parameters. So again, yp is this one. The standard form is this one. I divide it by both sides of the equations by x squared. So that's why this is 1. So you see this one, f of x, non-homogeneous part has been changed. It was like x to the 4, e to the x. Now it is x to. So Wronskian x, its derivative 1. Second one, its derivative here. Determinant, I get this, okay, x squared. Simple. u1 prime, we are allowed to use the formulas minus y2 fxw. I don't do any magic. So I just subbing to every parameters here. So I will get this one. So from here, u1 using twice integrating by parts, okay, because the degree of the polynomial is 2, and by the time its derivative is 0, so it's decaying in terms of derivative by derivative. So I will have this one, x squared. So I will write some couple of examples about integrating by parts. So x squared, I don't touch it. Integration of the second factor minus derivative of this one minus second expression has got minus 2x integration of this one e to the x plus derivative of this guy 2 e to the x. I can continue, but the derivative of 2 will be 0, so I don't have to write it. So u2 prime is this one. Again, I will have this one, and u2 will be x times e to the x minus e to the x. So yp is this guy. So don't leave like this. You've got the chance of simplification. So finally yp will be this one. So y is yc plus yp. Yc was this, and yp is this. Now, in the classic methods, if I had this one here, is that okay? If I had this one x squared times e to the x, I would use this one, yp times a x squared plus bx plus c times e to the x. And the mission was like finding a, b, c. Now, you see this guy here. Yp, like a is 1, b is minus 2, and c is 0. If I were using that one, I would get this one. Now, let's practice some integration. So let's assume that you got x 2 times e minus x. So so how many times the polynomial of degree 2, and it's decaying derivative by derivative. So what's the derivative of x squared is At first, I won't take derivative, but I will take the integration of e to the minus x. So integration of e to the minus x is e to the minus e to the x. Now, second expression will be minus. Derivative of x squared is 2x. Okay, now, what's the integration of minus e to the minus x is e to the minus x. Okay, now, second expression must have plus. Plus, derivative of 2x is 2. Integration of e to the integration of this one. If you had minus here, don't put it here. Just leave it here, okay? That's how it works for integrating by parts. Actually, this is generalized integrating by parts. Minus e to the minus x. Now, I'm done. Because after this expression, 2 will be 0. Let's see another example. So, 3x cubed plus 2x plus 5 times. So so usually the polynomial times something that we know that it's integral. Okay. So let's choose instead rather than exponential. Let's choose cosh. Let's make it simple. What's the integral of cosh x? Shine. Okay. Hyperbolic sign. So we call it shine. Yeah, sunshine. Excellent. So what's the derivative of order 0 of the first polynomial is 3x cubed plus 2x plus 5. The integral of cosh is shine minus the derivative of the first polynomial is 9x squared plus 2. Again, derivative of this one, shine, is cosh. The third expression, regardless of the whatever, like if there is minus here, I wouldn't put it out, so I will leave it inside parentheses. So again, 18x shine and minus 18 times cosh. This will be my let's do this one. X4 times sine of 2x, more annoying. Okay, so x4, what's the sine 2x integral? For x cubed, sine 2x is minus 1 over 2 cos 2x. What's the integral of minus 1 over 2 cos 2x is plus 1 over 4 sine 2x. Am I right?
That's still negative.
Yes. So I'm not right. Plus, so I wouldn't move this minus to outside. So this will be plus derivative of 4x cubed will be 12x squared times minus plus 1 over 8 cos 2x minus 24 x. Oh, what's that? Okay. I should be careful. 24. Oh no. Yeah, 24 minus 32 cos 2x. Okay, so you see that so we used like in a hidden way like 4 times integrating by parts. A side remark, but you know, in order to solve the ODEs, you should better to know these things. All right, so you will see these handwritings of mine, so you will get them. So in technique of the integrating, it's not important anymore because you've got the soft computing. But it's good to know. Question 2, part A. Again, it's about Cauchy equation. So as I said, you will have one question about Cauchy equation, but non-homogeneous one, not homogeneous one. So y equal xp, y prime is this one, y double dash is this one, x squared, p times p minus 1, okay? So after some simplification, I will have this one, and p squared plus 2p equals 0. So p is 0 and p is minus 2. So yc is this guy. Now, I need to get y prime c of this because it's initial value boundary. So initial value, it means y of 1, y prime of 1. So if these 1 and 1, if they were different, we had BVP, boundary value problem. I apply initial conditions, yc of 1, so I will get c1 plus c2 equals 0. Y prime of c1 equal 4 will result c2 to be equal minus 2. So, you know, yc is this one, so minus 2 times c2, 1. All right, so by having c2, I can get c1. So that's the particular solution. Question 3. So what you will have one questions about these questions in your mixed method. So when you have y prime to be exponented, the trick of solving these questions is like the change of variable like y prime equal to be p. So with part A solution in this tutorial solution, it's not correct. Okay, we will have the correct version now. Now, last week in the first session, you saw that you can have now you got y double dash y prime. You could have x and y. So you have 2 variables absent. Now, if you put y prime equal p, you need to discover what the y double dash is. Okay. So if there is x, then y double dash will be just p prime simple. But if there is no x, you need y double dash will be p prime times p. So let's see why. So y prime equal p. So y double dash is this guy, dp over dx. So I will use the chain rule. So dp over dy times dy over dx. It's like adding dy to the numerator and denominator. Times, not adding. So the first one, dp over dy is this one. P prime, when I said it's like, it means dp over dy. And dy over dx is p. In the tutorial solution, this p has been missed. Now, original ODE is this one, p times dp over dy plus p squared plus 1. So it's all separable. So you start to solve it. But since the question has been changed, the solution is not straightforward. So you got this one, p squared plus 1, absolute value is removed. That's obvious. Log is this one, 2 goes to here, okay, and minus 2, and that's why this is 1, this one c2. So I can hit the equation by exponential. I will get this one, p squared is this one, then square root of both sides of the equation. So p is y prime, p is dy over dx. So dy over dx is this one. Then we've got this one. Then we don't. So then we leave this one here because the integrating might not be easy. Part C. So last year, mid-semester, part C was the question like this. So y prime equal p again. So y double dash dp over dx. So x is absent. So I can't leave y double dash as this. Because I don't want to see x, so I will use dp over dy, dy over dx. So this will be p times dp over dy. So I will sub in the ODE and I will have this one. So factorizing, so or p equals 0 or stuff inside parentheses is 0. So p equals 0 means this one. P equals 0 is this one. So dy over dx equals 0. So last year, no one mentioned this part. So everyone after doing this part, just immediately move to this part. However, I didn't decrease mark for this part. But to this year, I will decrease. P equals 0, y equals 6.
Can we just go up the end and go, hey, 0 is also a solution and whack it in?
Pardon?
If we miss finding 0 as a solution in the working out at the end, can we also identify 0 as a solution?
0's solution.
Yeah.
What? Which part if we miss? Cons.
We can say y is 0, it's also a solution, but if we don't find that in the working out at the end, we just identify that.
No, y equals c is the solution.
Oh, sorry, y.
C. Yeah. At the end. Okay, if you like. But yeah, so this part is just one mark. But whole question will be 5 marks. So dp over dy plus 2yp squared, it's again separable, okay? And so separable, too easy. So this guy C1, then 2C1 I will call it C2. So lots of not unnecessary details. I have written it here. So this one, and again, the integration is easy. So, but the rest is not, the rest is easy. Just don't miss this part. The initial part is important. Like y prime equal p is the 50% of the work. The rest is nothing. Yeah. So that's why my handwriting is like 39 pages, because I had written like I don't do anything, but it's moving. Okay. It's 39 pages. Anyway, question 4. Okay. Why is it like this? Lecture 1, week 4. Okay. By the motivation of the variation of the parameters, we can discover Green's function. So Green's function yp is integral of this potential value from a to the x. This is a stupid question. Okay. Why is it like fx? Okay. So I'm recording and James will hear me. Okay. So yp is this one, and gxt is w Ronesian, y1p, y2x. So variation of the parameters, it's similar to that. It's not exactly like that. So gxt and w. So actually, the excuse of this question is just reviewing the method. No, now we've got the w. Now y double dash plus 16 y equals 0. So r2 square r plus 4 minus. So I can discover y1 and y2. Okay. So one thing, to like if you see any like question 5 marks, then 1 mark only is allocating to the finding solutions of the homogeneous part. Okay. So that's because it's easy. y1 is this one. Y2 is this one. Ronesian, so Ronesian is kind with us because it's -8. GXT, I will just apply. So you are welcome to write these things in your cheat sheet. GXT is this one. Bless you. 1 over 8. So I just change this guy. So because I want to remove this minus here. Here, okay. And therefore, YP is solving this guy here, GXT and FT. What is FT? We don't know. So this one and this guy looks like a sine for me. Hyperbolic sine. Hyperbolic version of sine is this guy. So if I multiply 2 here divided by 2 here, it will be sine. So that's why 1 over 4 appears here. And this one is since. Okay. So this guy YP here and YP is this one. So integral of sine 4 times x minus t, it's like the convolution. What's the convolution? You can look up that, but you don't need it. But I just want to give extra information. All right, let's do last question. Question 6 will be left to the next week because you don't need BVP in your assignment. You need IVP. So this now seeing this fx is a real fx. It's like you will see the importance of the Green's method. Now you see that YC is easy. Okay, y double dash plus y equals 0. YC is easy, cos x sin x, and its W Wronskian will be 1 because you know. So practice causes that without cancellation, I can tell you that W is Wronskian is 1. Now, without what's the good things of the Green's method? As in your lecture notes, GXT has got some properties. Actually, YP. Finding YP using Green's method has got properties. And what that is this. YP of 0 is 0. YP prime of 0 is 0. Okay, so this means without relying YP, you can get your C1 and C2. Okay, so finding C1 and C2 is not business of the YP anymore if you use Green's method. So YC prime, C1, C2, YC prime is this one. So
That's something for initial value and boundary value, or is it just for the base?
no, IVP. Okay.
Does it matter which side cause it y1, y2?
Yes, it doesn't matter.
You get plus or minus 1.
It doesn't matter which one.
Doesn't it change the Wronskian?
No. W of Wronskian of y1 and y2 is the same as Wronskian of y2 and y2. Because if you in determinants y1 and y2, if you flip them, they'll be the same. So because W of y1 and y2 is like this one is y1 and y1 prime, y2 and y2 prime is the same as y2 and y2 prime, y1 and y1 prime. So the Wronskian, but it's commutate.
Is it possible that the sign can change, but
No,
The sign would be negative when you flip this column, you've got
all right. Yes, okay. So I made a mistake, but if you change y1 and y2, then GXT also the formulas will be changed. So the negative will cancel each other. All right. So this is negative sign. I put negative here. Thank you. So now let's C1 and C2 are findable here. C2, YC is 0. So I can find C1 by subbing 0 here. Now let's compute YP. So W is this one. So Y1 is cos X, Y2 is sin X. Okay. GXT, so Y1 and Y2. So again, I will sub here not any mathemagic. So YP is this one, 0 to X, GXT, FT. Now, FT is like a real FT. It's like a pulse. Okay, it's It's a number in some limited time. Okay, so let's assume that x one time is less than 0 and 3 pi. Anyway, before doing this one, x less than 0, ft will be 0. So we don't need to calculate it. So yp of x is 0 if x is less than 0. So let's assume we've got this one, yp will be this one. So integral of this one. So I just sub here, and I just made a mistake here. But I want to use this one here instead of this guy. I can use the sign of the addition. So I will use this one. So I can get the integration very easily, subbing t0 and tx carefully. So I will get 10 minus 10 cos x. This is when x is between 0 and 3 pi. So let's assume that x is bigger than 3 pi. So if x is bigger than 3 pi and t is between that, so f of t will be 0. So yp will be from 0 to x, and I will divide that integral to 2 parts because ft changes. So 0 to 3 pi is a number. 3 pi to x, ft will be 0. So I don't count this one. So integral from 0 to 3 pi. Similarly, I will get, subbing everything here. Similarly, I will get my minus 220 cos x. So the important thing is like sine of a plus b is equal sine of a cos of b plus sine of b plus minus cos of a. So that comes from this part. So now that's why I'm able to write this inside parentheses like this, and it is easy to get its integration. So I will get this one minus 20. So y will be yc plus yp. Yc, this stuffs. We already had the c1 and c2 and 0 yp when x is in this interval, in this time. Yeah. What's one of the signals that it's time limited is the voice signal, audio signal. Part B is again, last thing. Part B is the Cauchy equation. As I said earlier, we obtain y1 and y2 without changing the standard form. So we will leave it as it is. But if we want to find yp, we will have to divide every equation by x squared because we want coefficient of y double dash to be 1. So again, using the appropriate change of variable y to the xp, and I will get my yc. Again, without relying yp, I can get c1 and c2. So then after c1 and c2 are determined easily, yc is here, and y1, y2, I fix them. Wt will be this one, t squared, and gxt is this one, and again, y1. So you write these formulas carefully in your cheat sheet. gxt, okay? And remember that w must be in terms of t, okay? Now, I obtain gxt. Now I divide x squared, so I will get this form, and yp is now kind. Yp is because f is fun. It's not annoying anymore. And from here, yp, I just take integration. Why I put 1 here?
0.
No, why I put 1 instead of 0? Initial condition starts from x equal 1. Look at this one. Initial condition is 1, 1. They should be the same. So the last, so yp 1, again, it's technique of the integration. It's not in technical integration, it's nothing here. Okay, so YP, I obtain it and I will put it this one here. This was the last one. Consultation time is at 12:30. And also you can email to me if you have questions. If I have time, I can answer, but usually I answer quickly. Have a good day ahead.